Today we're going to present to you the methods of charging. So it's important to know why we're presenting this. Because now that we know what the basic structures are, it's important to know how to practice, how to charge, how to understand the theory of charging and to practice charging. Lucy's going to take this.
Yeah, so basically there's four methods of charging. And first of all, I'm going to talk about bifurcation. So bifurcation means like there's two particles and they're neutral. They are not charged. And because of the electron affinity they have of the particles, that it's like a property they have by themselves. When they get contact with each other, the particles that have higher attraction of electrons get in touch with another that have a lower one, then this one will take off its electrons and become charged. So then the one that takes off the other one's electrons is negative charge, and the other one that loses electrons is positive charge. And by periodic table, that's from this line to here, so it's like the increase of the attraction of electrons. So the higher or more over here, they are like more attractive to the electrons than the elements over here. And also it's like it's the same that in our daily lives, like you know how when it gets to fall and winter and we get to wear sweaters, and then when we take off them or take off our clothes, we will hear some sparkling sounds, or when we touch something, we feel like there's a current goes through us. It's also because of that, you can see from here, dry human skin. So it's in fall and winter, the air is really dry, and we are not, and so as the human body, so we are more easy to lose electrons as usual. That's why we are become charged. And when we touch something that feels maybe like negative charge, because we lose electrons, we have positive charge. And we touch each other, because there's the transformation between the electrons, so there's current flow between us, then we will feel like there's current through us. And the second method of charging is by conduction. And by conduction, it means here is charged particles, and here's a neutral one. And these charged particles get in touch with the other neutral one, and it will charge the other ones. So it's like saying that, everything is made out of particles. So which means that we all have electrons by ourselves. And then when we are the charged particles, so it's carried either negative or positive charge. And then when it gets in touch with the neutral one, the electrons it carried by itself either attract by the charged particles or either pull away from it, and then the electrons from the other one or the charge from the other one pass through this the surface they got contact with, and then transform into the other neutral one. So which makes the other one charged. So in our life, it's it's really similar to bifurcation, but it's a little bit different. So you know how in fall and winter we curl over here and then or touch something else, who our body gets become charged. And then when we put our hand close to a paper, or when we put our hand close to your hair, and you can see that it's being attracted by it, and it's comes out of its surface. So that's just a process of conduction. So which means that your electron particles is being attracted it attracts the other ones, and you get contact with each other, and then the electrons is transported to another particles. This is a risk I combine by friction and by convection. So when we climb up here in the morning, and our the brushes has maybe negative charge because and the positive charge is left here. So when this is because positive charge is here, the negative charge is on the brushes, and then if you put these brushes near to the balloon, which is not charged before, and because it's near here, the positive charge is you may think that the positive charge is being attracted by it, but it actually is not, because positive charge is immovable, so it can be moved. So actually, it's the negative electrons here that being pulled away because they have the same property as a negative, so they being pulled away from these bushes. So it's here is negative. That's why here is being positive charge. It's not they are gaining any positive charge. It's just because their negative charge is being removed.
Oh. I thought there's another side, but okay.
Sorry.
So the third method is charging by induction. So similar to charging by conduction, the only difference is just that there is no physical contact between object A and object B. So in order to understand the concept, you need to know two required concept, which Lucy basically touched on. First is a conductor. Conductor is the material that permits the transportation of electrons from one object to another. The second concept is the process of polarization. It has a fancy name, but basically it means the separation of opposite charges within the same object. So how does it work? First, a pop can, right? It's neutrally charged. This is an example. So just imagine that this is a pop can right here. So if it's neutrally charged, then it has a even distribution of electric charge within the same object. And then you use a conductor. It's right here. This friendly. If it has a negative, if it's negatively charged, then if without physical contact, if you put the conductor really close to the neutrally charged objects, then then there happens to be a polarization happening within this neutrally charged object, because the positively charged conductor induces the opposite charges, which is positive charges in this area, and therefore more negative charges are going to the other direction. So this causes a uneven distribution, which is the polarization of electric charges within the same object. So that is kind of the process of induction. And this is basically a demonstration, but we don't have the tools here to demonstrate it. But that's how we relate it to the real life scenarios. And the fourth and the last method is grounding, which is how you remove electric charges. The first three are how you create or transfer electric charges. Okay, so the ground. What is the ground? The ground is basically an object that serves as a seemingly infinite reservoir of electrons. So it has a wide application in real life because if you remember.
All right, thank you very much.